very useful acetylating agent in organic chemistry, in the manufacture of some pharmaceutical products, but also illegal in most countries. That's acetic anhydride. It is used on the illegal transformation of morphine into heroin, and because of that, acetic anhydride appears in the DEA list 2 of chemicals. Despite that, acetic anhydride is an essential raw material for pharmaceutical industry, as it is used for the acetylation of paraminophenol and salicylic acid, producing paracetamol and aspirin respectively. Also, acetic anhydride is used on a very classic reaction in organic chemistry. This is the synthesis of acetanilide, the main star of this video. Acetanilide was formerly used as an antipyretic and analgesic drug, but later it was replaced with phenacetin and paracetamol. Acetanilide is metabolized into paracetamol in the body, making it a prodrug. The disadvantage is that amidases hydrolyze acetanilide, and the resulting aniline is very toxic. Acetanilide nowadays is more used as a building block. For example, you can perform nitration, chlorosulfonation, halogenation, and sulfonation in para positions, and after hydrolysis, you can get the respective para-substitute anilines. So, how does acetanilide is made? There are 3 main routes, all starting from aniline, and the first one is the direct acetylation using acetic anhydride and acetic acid as a solvent. Also, acetyl chloride and pyridine could be used, and the other one is employing acetic acid and zinc dust as a catalyst. As zinc dust is hard to get, acetyl chloride is toxic and difficult to store, and acetic anhydride is regulated in my country. Today we are going to synthesize acetanilide only using acetic acid and aniline. First, add 25 ml of glacial acetic acid on 4.1 grams of aniline. I made my aniline in this video, so take a look if you want. Then I let stir the solution for something like 2 days. After 1 week, I set up a reflux condenser and started heating. Please do not let too much time to happen between the distillation of aniline and this reaction because aniline could easily oxidize. While this is reacting, let's discuss what's happening here. First, between acetic acid and aniline occurs an acid-base reaction. This reaction is in equilibrium, of course. Then, 2 molecules of acetic acid forms a nitrogen bond, and then aniline attacks the carbonyl group, displacing an electron pair into the oxygen atom, leading to this intermediate. Then a proton transfer occurs, and oxygen forms a double carbon-oxygen bond, kicking away the water formed. This other intermediate takes place, and it has this resonance structure. Then acetate takes the remaining proton, and we get our final acetanilide. After 6 long hours of reflux, we finally shut down the stirring and the heating. In a beaker containing ice-cold water, we dumped our mixture while still hot. We have to also make some washings with distilled water. Let's set the crystals of acetanilide for some minutes. Then, I'm going to filter them using vacuum filtration. Don't forget to make some rinses using cold distilled water to remove any residual acetic acid. Then I transfer the crystals into a beaker. And rinse the beaker using distilled water. I added more water, approximately 90 ml in total, and I heat it till everything dissolves. When everything dissolved, I removed the beaker from a hot plate and let it crystallize. Unfortunately, I forgot to take a footage of it, so let's continue with the filtration. I filtrate the crystals, and as you can see, there are some discolored ones. I again make some rinses with distilled water. Then I transfer the crystals into a recrystallization dish. I put the dish inside the oven and dry it approximately 1 hour at ATC. I remove the discolored crystals using tweezers and my spatula, and you can see them on the left. On the right, there are the whiter acetanilide crystals. To finish this crop of crystals, I took the experimental melting point, and it resulted to be between 111 and 112, pretty close from the theoretical value. For the second crop, we have to concentrate all the motor liquors obtained on the filtrations and washings. I added sodium bicarbonate to neutralize the residual acetic acid, but the solution was very hot and it contained more acetic acid than I thought, so this happened. I learned the lesson and added bit by bit the sodium bicarbonate. When the bubbling stopped and the volume was approximately the half of the initial, I removed the beaker from the hot plate. I let the solution cool in a fridge for something like 1 hour, and when I turned back, these beautiful and hexagon-like crystals of acetanilide appeared. I filtered the crystals and transferred them into a recrystallization dish. I dried this second crop exactly the same as the first one. I took the experimental melting point of this second crop, and it was approximately 1 Celsius lower than the first one, so it's enough pure for me. To calculate the yield, I weighted an empty jar. Then I weighted the first crop and later the second crop. In total I got 3.77 grams of acetanilide, which represents a more or less yield of 63.3%. Not a bad yield considering the simplicity of the reagents. So well, there you have it, acetanilide synthesis without acetic anhydride. Thank you for watching and see you in the next video.